We have a question here, question 10. The question says, a rain gauge is in the shape of a cone. Water flows into the gauge. The height of the water is 8 centimeter when the radius is r centimeter. The angle between the cone edge and the radius cone is in the diagram below. Okay, is shown in the diagram below. So now we have the formulas here. Okay, and on question 10.1 says determine r in terms of h. Leave your answer in the third form. All right. What can we do then? Okay. So we need to find r. R is over here. We can see r is over here. We need to express. Where is it? Okay. We have r over there. So if I can write the triangle like well, we have another question here, question 10. The question says the rain gauge is in the shape of a cone. Okay, we can see this shape here. This is the cone. Okay, and then water flows into the gauge. The height of the water is 8 centimeters when the radius is r centimeters. The angle between the cone h and the radius is 60 degrees as shown in the diagram below. Now here are some formulas. The question says determine r in terms of h. Leave your answer in the third form. All right. If you look at this triangle here, because this is where r is, r and h are there, and then I can just reproduce the same triangle over here. We'll write first the question 10.1. We're looking for r. We need to express r in terms of h. In other words, r of h. I can call it like that. Okay, r of h. I can call it like that. R of h. That's determining r in terms of h. I can reproduce the same triangle. Okay, it's like we have like this triangle, this right angle triangle. Okay, no, that's not the right angle triangle. It's like okay, that's the right angle triangle, and then this angle is given to be 60 degrees, and that's h, and that r. Okay, now if I need to find r, how can I find r in terms of h? What formula can I use? What formula? We can use the tan formula, okay? Because tan of the angle is equal to adjacent over opposite of adjacent. Opposite of adjacent, okay? So we can say tan of 60 degrees will be opposite will be opposite angle 60 degrees h, and then adjacent to the angle is r. So this will be tan 60 will be equal to opposite h over r. So if I need to find r, then we can, it's like over 1. Okay, before I even do that, tan of 60 degrees is how much? So how do I know 60 degrees is a special angle? We can substitute the values like 60 degrees over here. So that part must be square root of 3, and that's 2, and that 1. Okay. Tan of 60 degrees, then opposite of adjacent will be a square root of 3 over 1. So that's going to be square root of 3 over 1. Okay, h over r. Now, if I need to find r, just split it. Okay, we can just do over here. We can cross multiply. This with that. So we have like square root of 3r times r equal to 1 times h. And then if I need to find r, I divide both sides by square root of 3, square root of 3 over square root of 3. And then I've left with r equal to h over root 3. That's the value of r. Good. In terms, that's r in terms of h. So as I said, I can write it like r of h. Okay. question 10.2. The question says, determine the derivative of the volume of water with respect to H when H is equal to 9 centimeters. Okay, the volume of the cone is given is here. It's 4/3 pi r cubed. So I'm going to move my body a little bit over here. Say 10.2. Okay, the volume of cone. So we need to find the volume of the cone, and then the volume of the cone is given by 4/3 pi r cubed. Okay. Now, the derivative of the volume will be we differentiate with respect to h. So let's first substitute the value of express the v in terms of h also. So this will be v equal to 4/3 pi. Oops, it's pi. Pi r squared h. That's the volume of the cone. So now this will be. I wrote the wrong formula. It's the formula. The volume of the cone is 1/3. It's actually 1/3 pi r squared h. Yes, that's the correct one. So over here it must be then 1/3 pi r is h square root of 3. So I might leave it like that, r squared h. So this will be I substitute the value of r, okay, because if we find r over here, h over square root of 3. So this will be h over square root of 3. And then the volume will be written as 1/3 times pi, okay, times h squared over 3, because the power of 3 here is for the h, is also for the square root of 3, times h. So this is like, the volume will be 1/9 pi h to the power of 3. Now the derivative of the function of the volume now, so dv over dh with respect to h, this will be 1/3, actually. It's going to be like 3 times 1/9 times pi h squared, okay? Because 3 minus 1 is squared, and this will be 1/3 pi h squared. Now, the question says that when h has the value of 9, so the derivative of h has the value of 9, so I can write it like dv dh, when h is equal to 9, this will be 1/3 pi h squared, okay, when h is 9. And then this is like 1/3 times pi times 81. And 81 divided by 3 is 27 pi. So this is dv dh when h equal to 9. So that's the volume of the pi when water was at 9 centimeters. Right, thank you.